Okay, so today, the worksheet we're looking at today is called Circles Tangents, which probably means I need to talk a little bit about what tangent is, which isn't quite the same thing as if I said tangent when we're looking at the right triangles and things like that. It's not necessarily opposite over adjacent that way. What a tangent is in this circumstance, tangent, a line that intersects a circle in exactly, I should say at, let's change that to at exactly 1 point. Tangent, a line that intersects a circle at exactly 1 point. That is known as a tangent line. And then over here, I'm going to say tangent lines form right angles with the diameter or radius. So when we think of sine, cosine, tangent, we think of right triangles. And this, we're still going to be kind of thinking of right triangles also, because we form a right angle. So it does have some similar things. But when we talk about tangent, when it comes to a circle, we're talking about a specific part, a specific segment. And here in a little bit, when I move it, I'll label some different things. Are we all right? So let's see a couple of people copying. I think we're close. So let's take a look at the problems. So we have these two circles. So I have my circle here. This segment here, that's the tangent. So notice this tangent line is going to come up here and hit the circle at exactly 1 point. Now, does anybody recall this segment here that goes from one side of the circle to the other side through the center? Does anybody remember the specific name for that segment? This segment right here that goes from one side to the other through the center? Diameter. And that was actually one of the vocab on that quizzy thing. So this is a diameter. That's a diameter. And I said that the tangent and the diameter form a right angle. Oh. And because it forms a right angle, I now have a right triangle. Yeah, you thought we were done with right triangles? I said we were kind of done with right triangles, but they never completely go away. So we have a right triangle again. And if I know two sides of a right triangle, and I'm trying to find the third, what do we use? A squared plus B squared equals C squared. Good old Pythagorean theorem. Yes, it is made an appearance. It has an encore presentation. The Pythagorean theorem never really goes away. The C is always the most important thing. So the C, which one of these three sides is going to be in the C position? The 14.5, because it's always the biggest side. And if you can't tell what's the biggest side by how long it's been drawn, look for the 90, kind of follow it across. So x squared plus 10 squared equals 14.5 squared. That's my setup. Well, 10 squared is 100. 14.5 squared is 210.25, 210 and 25 hundredths. I want to solve for the x squared, so I'm going to subtract 100 from both sides. So x squared equals 110.25. Now remember, the last step is to get rid of the square. So I've got a square root, 110.25, and I get 10.5. So this is the last thing I needed. So yeah, even though it looked different than some of the ones we've done before, because there was a circle sitting behind it, it was still something that we'd done in the past. There's really nothing new there. Now the next three all have a slight little twist. Sometimes the twist is at the end, sometimes the twist is at the beginning, but there's a little twist to it. So let's take a look at number 3. So number 3, this segment here, that's the one that's running right next to the circle. So in this case, that's the tangent. Now this segment connected at the edge of the circle and went to the center. Does anybody remember the name for the segment that goes from the side to the center? Radius. So that 3 in this case is a radius. But I've still created a right triangle. So here's my right triangle. I don't know this whole side, so I'm going to actually put an X there. But in the end, that's not going to be my final answer. My final answer is going to be what's the question mark. So it takes an extra little step at the end. So in this one, what's going to be my C position? What has to go last? The X, because this is the biggest sum. So 3 squared, 4 squared, x squared. 3 squared plus 4 squared equals x squared. Well, 3 squared is 9, 4 squared is 16. Everything's on the same side, so I can just add this together and get 25. The square root of 25 is 5. Now, that's not my final answer, though. That told me that the side of the triangle from the center to out here is 5. But I need to figure out the question mark. So to figure out the question mark, I really need to figure out what this segment is. Is there anything in this picture that would tell me how big from this dot to those 2 points would be?
Wouldn't the 3?
It would be 3. Because once I know one of the radius is 3, I know all of the radii are 3. So this radius is 3, this radius is 3. So this is 3. What's left for this little guy? 2. That's my final answer. So that's the one I'm going to circle. So it's real important when you're doing these right triangle ones, you circle what's your final answer. Because this one took a little twist at the end. 1 and 2, are we okay? Let's scroll on. 3 and 4. Now, I've got my right triangle. I gave you this side here, which is 20, and I know it's that full side because I've got those little marks all the way across. This full side, I didn't give you yet, but I've got an 8 sitting there. So if this is 8, what would be that entire side of the triangle? From here to here is 8. So from here to here must be, here to here is 20. Well, this goes to the center. If to the center is 8, all the way across is going to have to be, there you go. Because this is a diameter, and I actually just gave you the radius. So if the radius is 8, the radius is 8, the entire diameter is 16. So it actually took a little twist at the beginning. So sometimes the twist is at the end, sometimes the twist is at the beginning. So now I have 3 sides. I've got the one I don't know. I've got 20 and 16. In Pythagorean theorem, what goes last? Which one will go last in this one? The 20 is the biggest side. This is my 90, so I know it's the biggest side. So x squared, 16 squared, 20 squared. The longest side has to go last. 16 squared, 256. So x squared plus 256, 20 squared is 400. Subtract the 256, I get 144. Square root of 144 is 12. So therefore, this side here is 12, and that's what I was trying to look for, so that's my final answer. So 12 is what I was looking for. Now, number 4 is almost exactly the same type of question as this one, because I'm still giving you this full side. This segment, I only gave you the 6, so that means the entire side is going to be what? What's the entire side there going to be that I just marked in red? 12. Because if this is 6, this is 6, so the whole thing is 12. And I'm looking for this one. So therefore, x squared, 12 squared equals 15 squared. That's my Pythagorean theorem plugged in. A squared plus b squared equals c squared. And the hypotenuse has to be the last thing. It will always be the longest side of a right triangle. Well, 12 squared is 144. $15 squared is 225. If I take 225, subtract 144, I get 81. Square root the 81, square root the x squared, x equals 9. So 9 is my final answer here, and that's what I'm going to go ahead and circle. So a tangent line. A tangent line is a line that touches the circle at one point, one exact point on a circle. That point where it touches the circle is also going to form a right angle to the radius or diameter. So that's my right angle. And because I have a right angle, I can go ahead and connect all 3 things, and I end up with some right triangles. So that's why we work with right triangles. So that's what we were looking on 1, 2, 3, 4. Are we okay? 1, 2, 3, 4. Now, if you notice 5 and 6 changes, they don't look like these. They look like something else. We all good? Drew, you still with me?
Yep.
6. So on this one, now if you notice, I've got a tangent line here, and I have a tangent line here. So these two segments are tangents, and I've got a radius and a radius. Now, I'm actually not even going to use the radius. My rule is if two tangent lines intersect outside the circle, then the segments are equal. If two tangent lines intersect outside of the circle, then the segments are equal. So I have these two tangent lines. I know they're tangents because they're going to touch the circle and spot. They come out, they intersect. So that means this segment, which we said was 9x minus 2, is going to be equal to this segment, which we said was 1 plus 8x. Those two are equal. Yes, I have another number in there, the 13.3, but I don't really need it. It's there to kind of throw us off. Now, I'm going to flip to a different picture before I solve this. But in geometry books, there's just some random name that they give to this particular theorem. But all geometry teachers, everywhere almost, have come up with a nickname for this particular theorem. And the nickname. Did everybody get this written down? Because when I click the mouse button, it's going to disappear. Okay. Is the ice cream cone theorem. So, my ice cream cone theorem. If you notice, this kind of dip of ice cream kind of looks like a circle. So, I've got a circle sitting on top of a cone. This is a sugar cone because the sugar kind of comes out. So these two segments here kind of look like the tangent lines that intersect. And you always want to make sure that this side and this side stay equal, because if your sugar cone is misformed, your ice cream might fall on the floor because it's not balanced. And you really don't want your ice cream to fall on the floor because it would make me cry because I really like ice cream. So almost every teacher calls it the ice cream cone theorem. So let's come back here. I'm going to go ahead and put that up here. And I'm going to put in parentheses because it's not the real name for it, of course. It's just kind of a nickname. Ice cream cone theorem. Ice cream cone theorem. So again, this gets set equal to this. That's all. 9x minus 2 gets set equal to 1 plus 8x. Yes, there's a number here, but I don't even need it. It doesn't really do anything for me in this problem. It's just there to kind of throw me off guard. Subtract the 8x. 1x, which is just x, minus 2 equals 1. Add the 2. X equals 3. So therefore, my x is 3. I mean, I could have you plug it back in, but I didn't. X is 3. You're going to do the same thing on number 6. Set the two sides equal. Because you want to make sure your cone is balanced. If it's not balanced, your ice cream is going to fall on the floor. We don't want to waste good ice cream. So 7x minus 6 equals 5x plus 10. Set them equal. Subtract the 5x. 2x minus 6 equals 10. And I didn't give myself enough room. Add is 6. So 2x equals 16. So x must be 8. So x is 8. Definitely one of the easier theorems out there. And the first 4 aren't bad either, especially since we've done Pythagorean theorem before. They're just a little tricky at times. Any questions on those 2? Still see a couple people writing. Now, the next 6 are what you're going to work on. So let's look through. 7 is just like number 1. I gave you 2 sides of the right triangle. You're figuring out the third. Number 8 is just like number 2. I gave you 2 sides of the right triangle. Yes, you need to figure out the third, but that's not your final answer. The final answer is what this little piece is, this little segment that sticks out. So it takes an extra step at the end. Number 9, I gave you 2 sides of the triangle. You're going to have to figure out this total side. But again, it is a little twist at the end because I don't want to know the entire side. I want to know to the center. And then number 10, there's a little twist at the beginning because I give you the 5. I give you 2, which is only to the center. So you got to figure out the total side so you can get the other side. So 8, 9, and 10 each have a little twist. 11 and 12, you're just going to set up equations, solve for x. So go ahead and work. When you get done, you can show it to me, and I can mark it. If you don't get done today, that's okay. We can mark it tomorrow. We will mark it tomorrow. Don't forget, finish your projects.